guys to do for me, because you pretty much already know how to do it, except for I just haven't graphed it for you yet. So we're going to do the first one together, and I'm going to get you guys to do the next 5 for me. So we're finding the slope of the line now that passes through 2 points. Okay? So all the problem is going to give us is 2 points on the line. Now, how many points do you need to identify a line? Just 2, right? Because if you have 2 points, there has to be a line that goes through those points, right? So if you have 2 points, you can find the slope of that line. So I've just got some here that we're going to do. So we've got 4, 5. So right now I want you to graph it. 1, 2, 3, 4. Up, 1, 2, 3, 4, 5. Here's this first point. Yep. So you go to the right 4 and up 5. Because this is your x-axis. This is your y-axis. This is your x-coordinate. This is your y-coordinate. All right. -1, 3. -1, 3 would be right here. So we'd be looking at this line.
I think the only thing that could be made essential, like when we're like doing counting stuff, it's like the y is on the front. Like I just get I think
whenever we do the slope,
yeah.
The second one is your top for the slope. Is that what you're talking about?
Okay, wait. So the second one is the left to right.
No, so you're talking about graphing the points,
Yeah,
right? So graphing the points, the first one goes left to right. So 4, you're going to go to the right. 1, 2, 3, 4. So right here is 4 on that x-axis, right? So, and then the y is how much you go up or down. So 1, 2, 3, 4, 5. Right here's your 5. So it's like if you put your finger at 4 on the x-axis and your other finger at 5 on the y-axis and you like meet, you would end up right here. Okay. And for the -1, 3, -1 is what right here. 3 is right here. So the coordinates of that point, like if you took -1 and 3 and you met, they would end up right here at this point. Okay, so we want the slope of that line. I need to know rise over run, right? So how many do I have to go up or down? 2. How many do I have to go to the right? 5. Should my answer be positive or negative? That line is going up from left to right, so positive is correct. So this is our answer. Okay, so I want you to do that for the next, all of the ones that have graphs there. So do this for all of the ones that have graphs. And as far as I can. I can't go past there though. Oh my God. Let's see. What will happen if I do that? Okay. Alright, so -5, 6, -5, 6 is going to be right here. And 0, -1 is going to be right here. So we're looking at the straight line that passes through those points. And so to count that, you're going to go down 1, 2, 3, 4, 5, 6, 7. So since down it's -7, and then right 1, 2, 3, 4, 5. So -7/5 for that one. Okay, questions? All right, so this time you've got 4, 0 should be here. 0, 6 should be here. So you're looking at this line here. You got 1, 2, 3, 4, 5, 6. That was down, so I'm going to put -6 over 1, 2, 3, 4. Now, I don't want to leave this like this. What should I do? I got to simplify it. What does it simplify to, Jada?
Well, I did this wrong. Never mind. Negative 3.
Negative 3 over 2.
Oh, 0 over the same.
Just reduce it. Okay, so make sure you've got these right. Here, questions so far? Yes. You went the wrong way first, I believe. Or you graphed your points wrong. It could be either one. But you should have a point right here at 4 on the x-axis, a point right here at 6 on the y-axis. So if you've got that right, then you got to make sure you go up or down first, so you got to go down 6. So you may have went left or right first for that one. Okay? For number 4, you're going to get negative 2, 5, which is right here, and 4, 5, which is right here. So what kind of line do you end up with? It's a horizontal line, which has a slope of 0. We don't say no solution, but we do sometimes say no slope. That would be okay. We're probably going to see 0 more often than no slope, but we may see that sometimes. Yeah. Correct. Notice this right here. If they have the same y coordinate, it's going to be a horizontal line. Okay, questions so far? All right, number 5. Here I've got the point 8, negative 1, which is right here, and 8, 6, which is right here. That is a vertical line, and vertical line is where we have undefined. Now, there are a lot of instances where we don't want to graph this. It could be that our numbers are too big to graph. It could be that your teacher copied it too small and your graphs are tiny and you can't see them. But there's a lot of times when we don't want to have to graph this in order to find that slope. So, we're going to look at this situation. I've got the point x1, y1, x2, y2. The ones and the 2s are what we call subscripts. Subscripts are small and below the text, right? So, whenever you write them, they're little and they're low. An exponent is little, but it's high, right? That would be, it's also called a superscript. They're up high, but subscripts are low. So this is just telling us the first x and the first y, and the second x and the second y. Okay, first x and first y, second x and second y. So, obviously, I can't really graph x1, y1, and x2, y2, because they're not numbers, right? But, for us to think about it, how this relates to the graph, I'm going to graph just an imaginary point and call it x1, y1. So, I'm going to pick this point right here. You can put it anywhere you want, but I'm going to put it right here, x1, y1. And then, I'm going to pick this other point somewhere else. I'm going to put mine up here in the corner. I'm going to call it x2, y2. So, whenever I'm looking for a slope, right, I need to know how far this distance right here is. Now, if I use the points that I've got here, I could count them, but this is x1 and y1, like they're not set points. I can't count, I could count what I've graphed here, but that would just be for these points. How else could I figure out how far apart or how tall that line right there is. I could count, but in this case, that would only be for like where I've graphed them, because we could move these all over the place. We could put them anywhere. So it would only work for like this one time here. What if I told you this y coordinate right here was 9 and this y coordinate right here was 2? What can I do with those numbers that would tell me how tall that is? If I subtracted them, 9 minus 2 would give me 7. That is 7 right there, right? But these are arbitrary points. We don't know what they are. So instead, I'm going to say that the length of this line is y2 minus y1. I subtract my y's, right? And actually, wherever they're at, if you subtract your y's, it's going to give you the length of that green line I've just drawn in there. Okay? Then I would need to know how far to the left or right I have to go. Okay? So, I could also here subtract my x's, right? The x coordinates here. So, for example, this is actually at 6 and this is actually at 9. I would do 9 minus 6 would give me 3, right? So, I could do x2 minus x1. So, if I wanted to know the slope for this, I could take the length of that green line, which is y2 minus y1, and divide it by the length of the purple line, which is x2 minus x1. That would be the slope through these points. So, this is a rule that we're going to call our slope formula that you need to know from now until the end of time. We're using slope formula right now in calculus. So as long as you're in math classes, you are going to talk about slope of a line. So the slope formula, let's write over here. I think it comes from a French word. I can't remember, but for some reason we always use the letter M for slope. So M is our slope. So M equals y2 minus y1 over x2 minus x1. So make sure you have that written there where it says slope formula. Okay, write this down. So this formula is very helpful because we can use it whenever we are trying to find slope, but we don't want to graph something. Okay? So, if I look at the points that I have here, 4, 7, and negative 3, 8, I didn't provide you a graph here. I don't want you to graph it. If I use slope formula, I'm going to let one of these points be x1, y1, and the other one be x2, y2. It really doesn't matter which point you pick. You could switch what I have right here. You just have to make sure if 4 is x1, then 7 has to be y1. And if negative 3 is x2, then 8 has to be y2. So it couldn't be like x1 and y2. So this is the first point. They should both have 1 as their subscripts. These are second point. You should both have 2 as their subscripts. So all you have to do here is plug this in. Okay? So I'm gonna write down the formula again. M equals y2 minus y1 over x2 minus x1. So Peyton, what is our y2? Mm-hmm. Good. So on the top, we'll have 8 minus 7. Okay? On the bottom, Caroline, what is our x2? Okay? So it's really important here. We can't do 4 first because we put our y2 first, right? Our 8 came first. So the x2 has to come first, right here. So it's got to be a, it does look a little like a y, that's an x, right there. So it's -3 minus, and then my x1 is 4. So, like, since I chose the 8 first in the top, the -3 has to come first in the bottom. Now, I could switch that. I could put the 7 first here, but I'd also have to put the 4 first here. Okay? So, if I subtract 8 minus 7, I get 1. What is -3 minus 4? -7. So, I would get -1/7 as my answer here. This is particularly helpful whenever you have larger numbers that would be difficult to graph anyway, right? So, if I'm going to do the slope formula for this, it's y2 minus y1 over x2 minus x1. That just means second y minus first y over second x minus first x. So, Vince, which one do you want to let the y2 be? Okay, so 0 could be my y2, 18 could be my y1. It's your x-coordinates you're subtracting. So I have 0 minus 18 over, and then, let's see, Katie, what about for my x's? Good. So what would that look like when I plug it in? -22 minus 10. So in the top, Zane, what do I get in the top? Good. And Peyton, what do I get in the bottom? Nope. It's going to be negative, but not 22. 32. Got to add those together. Okay. All right, now, if I have negative over negative, that becomes positive. So they're going to become positive. And I think that will reduce what could go into both of those. 2 will definitely go into them. I believe 3 will also go. So 6 is your best bet. Right? 6 is. No, I'm thinking 36. I think we're going to have to do 2. When in doubt, just do 2, and then you can reduce it again if you still need to, right? So you would get 9 over 16. Yeah, that won't reduce any further. 16 doesn't get, 3 doesn't go in 16. Yeah. So you just have to leave it 9 over 16. Okay, questions? Okay, so this can be used in context as well. All right, Johnny is running a race at 2 minutes. He ran 1.5 laps. At 10 minutes, he had ran 6 laps. For this time period of the race, how fast is Johnny running in laps per minute? Okay, so you've got minutes and laps. Minutes is going to be our x. So this point would be 2, 1.5. Right, so we could make that a coordinate. So if this is 2, 1.5, what would the other coordinate be? 10 and 6. Right? So I could use the slope formula for this because this one's laps per minute. Right? This was minutes right here. This was lapse. So the y is your lapse. The x is your minute. So you want slope because you want change in y over change in x, which is change in lapse, because that's what we use for our y coordinate, right? Over change in minutes. So you're going to make coordinates out of your information. Now we're just going to use that slope formula. So that's y2 minus y1 over x2 minus x1. So I'm writing it every time because I want to reiterate. If that's the case, you don't necessarily have to write it down. So what would we put in the top for this one, Passion? What are our y2 and our y1? Okay, we could use 6 for that y2. And then what would our y1 be? It's not 10, because 10 is an x-coordinate. It would have to be 1.5. So you're subtracting your two y coordinates is what's happening there. Okay? Then, since we put 6 first, 10 has to be first on the bottom. Right? So they came from the same point. So we'd have 10 here. What would we subtract from that, Passion? Our 2. Okay, so 6 minus 1.5 is going to give us 4.5. And then 8 on the bottom. Now, in this particular case, I'm not going to have you go get calculators just for these two problems, but we're going to use a calculator here. So I'll do that for us. So we got 4.5 over 8. And so we got, I'm going to go with a decimal here because what we want is we want to know how fast in laps per minute. So 5625. Try to keep at least 3 decimal places for me. If you keep more decimal places, that's always okay. Just don't keep less than 3 unless I tell you otherwise. Julian, take your hood off, please. All right, and this would be laps per minute because that on top, 6 and 1.5, those were our laps, and 8 was our minutes that went by. Okay, questions on 9? All right, so Caroline is saving money. At the beginning of the year, she had $320 in her bank account. By October, she has $1,150 in her bank account. How much money has she been saving per month? So the first thing we need to do is make some coordinates here. So we got 2 pieces of information. At the beginning of the year, she has $320 in her bank account. They're going to be big, and that we're going to use a calculator on this one. I'm not going to get you to go pick them up because most of the stuff you're going to have today is not going to be big, so you're not going to need them. But we are going to use a calculator. So, beginning of the year, she had $320 in her bank account. So, the beginning of the year, what month is that going to be for us? January. What number do you think we should use for that? Let's use a 1. Okay? And that's going to be $320. October, she has $1,150. What should I do for that? 10, $1,150. And we'll assume, I probably should have put this in the problem, but we'll assume this is from like January 1 to October 1, right? Because if it's the end of October, that would change what we would put here. But we'll just assume this is 1st of January to 1st of October. Okay? All right, so Caroline is saving money here. We need to know how much money she's been saving per month. So our money is our y. It's got to go on top. So our slope that we'll get here is, again, y2 minus y1 over x2 minus x1. So we would get 1150 minus 320, because those are our y coordinates, right? These are in the y spots. So 1150, 320, 10, take away 1. So again, I'm going to use the calculator here. 1150 minus 320 is going to give us 830 over 9. So if we take that and divide by 9, she has been saving 92.2 repeating dollars. Because this is money, I'm going to round it to 2 decimal places. So she's been saving $92.22 per month. I do need to add just a couple extras because there are a couple types I did not give you for slope. So make this example 11, add this here. This is going to be slope between 2 points, 4, 7, actually let's make it 4, -7, and -6, -7. And let's make them all negative. -4, -7, -6, -7. Alright, so, Marley, what would I put in the top of my fraction here for my slope? Okay. Alright, -7 plus 7. How'd you get that plus 7? Good. So I'm going to write it this way, minus -7, but just like Marley said, that's going to turn into -7 plus 7. If you go ahead and do that in your head, that's very good. I just want to make sure everybody sees where that's coming from. So it always has to be a minus sign in between, but if you are subtracting a negative, it's going to become a plus sign. Okay? So that was our y2 minus y1. All right, Easton, what's going to go on the bottom?
-6 plus 4.
Good. It's going to be minus -4, which is going to become -6 plus 4. So I wanted you to see one where you got that double negative. You got to switch it around. And I wanted you to see this happen, because what do we get in the top? What do we get in the bottom? What is that? 0. That is not undefined. It is 0. Right. Undefined is whenever 0 is on the bottom. All right, one more. Um, 4, -3, and 4, 7. Okay, I'm hearing it's going to be undefined. Why do you say that, Katie? X is repeating here. So when I do y2 minus y1 over x2 minus x1, I'm going to have 7 minus -3, which is going to turn into 7 plus 3. But on the bottom, I'm going to get 4 minus 4. Okay? So that's going to give me 10 on the top, but in the bottom I get 0. This is undefined. Okay, because we haven't had a chance to do any of the work in class, I do not want to assign something right now. So if you are all caught up, then you're off the hook. If you owe me something, I want you to work on your missing work tonight. Okay? Double check to make sure I'm right about that. I think the only thing we're missing is the one you gave me today, so I think we're okay. Double check and make sure.